Everyone, welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 2125, number of laser beams in a bank. Anti-theft security devices are activated inside a bank. You are given a zero index binary string array banks representing the floor plan of the bank, which is an m by n 2D matrix. Banks of I represents the ith row consisting of zeros and ones. 0 means the cell is empty, while 1 means the cell has a security device. There is one laser beam between any two security devices if both of conditions are met. Okay, what are the conditions? The two devices are located on two different rows, R1 and R2, where R1 is strictly less than R2. Okay, that means a laser beam can only start from a row which is lesser in index to the higher row. Okay, it cannot be vice versa. Okay, from here a laser beam can go towards the downward direction. Okay, and for each row I, where R1 is less than I is less than R2, there are no security beams in the row. If you see here, there are no security beams. As a result, there is a laser between these security devices. Okay, here if you see, there are no security devices in between, so there is a laser beam between these two security devices. Okay, so if you see the constraints are also like lesser in number, and if you see from this security device, it can basically send a laser beam to all the security devices in its next security row. Okay, in its next row, right? It cannot send it to this row, it can only send it to this row. Okay, so we have, for every adjacent row which has a security devices, how many laser beams it can send is all we have to identify. Okay, from this row to this row, we can actually send how many laser beams. The number of security devices present in this row times the number of security devices present in this row would actually tell us the laser beams from this row to this row. Okay, so here we have 3 security devices, here we have 2 security devices, so the total number of laser beams from row 0 to row 2 is basically 3 times 2, which is 6. Okay, and from this row to this row we can send 2 times 1, which is 2. The total laser beams would be 6 plus 2, which is 8. Okay, that is answer. Okay, so all we have to do is to identify in each row how many laser beams we have and calculate the in each row we have to calculate the number of security devices we have and calculate how many laser beams we can send between two adjacent rows which has security device. Okay, so I've just written the code. Let me walk you through it. So I have just taken rows as a variable, which is the length of the entire bank. Okay, and I've defined an array whose size is equal to the rows, and then I just populated these devices with the devices in the particular row. Okay, so I'm just iterating through each floor and just counting. Wherever I have one, I'm just incrementing my count in each floor, and then I'm setting the devices of the particular floor as the count. Okay, so this way, by the end of this algorithm, I will have this array as the devices at each floor. Okay, now all I have to do is to go through this array step by step and calculate the number of laser beams I can send, right? So I've just defined a variable called previous equal to -1 so that I can identify. See this for the first row, I can only send laser beams to this row whenever I have a laser. I have a row which contains a security devices, right? So in the initial, I don't have any row which has a security device. So the first row or the 0th row to the 0th row, there won't be any laser beams. Okay, so just to keep track of whether I have a first either I have a row which contains security devices, I define previous equal to -1, and answer is basically the overall laser beam which we have. So the moment I encounter a row which contains non-zero devices, I will first check whether is there any row which contains devices or not. If there are no devices, if it contains any devices, okay, that means I have to just multiply the devices in both the rows. Okay, so the devices at which I am currently standing times the devices in the previous row. Okay, the moment this calculation is done, I will set this current row as my previous. Okay, and I will just move to the next row. Okay, this way initially this will be set as previous because this condition will not be satisfied. Okay, so initially previous will be this, and my j will eventually reach over here, and then I will basically multiply my current devices with this previous devices. So my answer would be, at this point of time, my answer would be 6, and then I will again set this as previous, and the next iteration my j would be here. So the answer will be incremented by, since previous is not equal to 1, answer will be incremented by 2 times 1, which is 2. So answer will be incremented by 2. So 6 plus 2, which is 6. So that will be our final answer. Okay, let's try to submit this. As you can see, this all the test cases are passed and our solution is pretty efficient. Let's analyze the time complexity and the space complexity. So we are using a devices array of size equal to the rows. So this would take order of n, and in terms of time complexity, we are just iterating once in the entire floor for each floor, right? So it will be like n, this is of size n, right? So we have total n banks, so m times n would be the overall time complexity, and the space complexity would be order of m. Okay, that is all about this problem, and do subscribe to my coding channel for more such coding videos. I've seen people are not subscribing but still consuming. I highly recommend you to subscribe so that you won't miss the daily content I'm posting. Yeah, let's grow together and let's upskill together on daily basis. Thank you.